Okay, example 4 here is going to be the first one where there's a little bit of like actual math to do beyond dividing a number by 2 or multiplying by 2. Um, as you can see in the picture, we're kind of constructing a right triangle within our circle, within the confines of our chord and our diameter. We're kind of adding this dotted line to make a right triangle. So you can expect whenever you see a right triangle that what you're going to be doing is you're going to be using the Pythagorean theorem at some point. So let's go through and see what they want. The record shown can be modeled by a circle. Okay, basically a circle. Yep. Diameter CD from here to here is 12 inches long, and chord FH is 10 inches long. Find EG, the distance to the chord. Okay, so this distance right here. Okay, well, let's draw the picture they have and let's kind of label it with what we know. So we've got a circle, roughly. We've got a chord. We've got a diameter. We've got the center. And then we're going to draw out this little radius that goes out to the outside of the circle. Okay. Now, they say the diameter is 12 inches long. So we're 12 inches all the way across, which means halfway across should be 6, right? Well, halfway across is our radius. It's our distance from here to the outside. So while we could, label this as 6 or this as 6, those two parts being labeled is not really going to help us figure out the distance right here of EG, right, from the center out to that point. That's what we're trying to figure out, so that's what we want. Now, it says the chord is 10 inches long. Well, if the chord is 10 inches long, then half of that chord should be 5 inches, which gives us 2 out of the 3 sides of our right triangle. As soon as we have 2 pieces of information on a right triangle, we are set to figure out everything else, whether that's 2 lengths, 2 angles, a length and an angle. Right? As long as we have those 2 pieces of information, we can usually go from there. Okay, so what do we have now? We have 6 and 5. So we want to do our Pythagorean theorem, a squared plus b squared equals c squared, where our a, let's call this our a. So we'll have a squared, we'll have 5 squared, and always remember your longest side, your hypotenuse, is the c value. So we'll have 6 squared over here. So a squared and 25, 5 times 5 equals 36, 6 times 6. At this stage, if we want to figure out what a squared is, we'll just take away 25 from both sides, leaving us with 11. And we don't want a squared, right? We want to know what that distance is, just a by itself. So not a number times itself, but just what that number is going to be. Well, the square root of 11 is going to be our answer, because if we take the square root of 11 times itself, so if we take what I'm calling a right now, take that and I square it. If I take this thing, I square it, well, the square and the square root symbol cancel out, and I'm left with the 11 that I wanted. So a is the square root of 11. That is our distance from E to G. Okay, so occasionally we'll be using right triangles in conjunction with circles to kind of find certain measurements within the circle. Okay, but that is it for example number 4.